Okay, so this one is an arithmetic series. So it's a series of some terms, some numbers, and we can see that difference between successive terms is a constant. So from here to here this is 2, here to here this is 2, third term to fourth term is 2, so it's always 2. So the difference is 2. So the difference is constant. We can denote the difference with the letter D. Usually that's what it is done. So difference is 2. And when that happens, we call it an arithmetic series. So arithmetic. So basically, when we have such a series, we can find the sum from the information of how many terms are there, that is number of terms, and what is the first term, which is a. So here the number of terms are 5. There are 5 terms here, and a is the first term. So that is 1 here. So what we can say, the sum is, the formula goes something like this: n over 2, 2a plus n minus 1 into d. This is the sum. Also, when we have such a series, we can find a particular term. What's any particular term? So if we want to find the fourth term, or we can say the nth term, like fourth term or fifth term, or in general we can say nth term. So that is something like this. Any term, say nth term, is going like that: a plus n minus 1. In this case, n is nth term, what d. So let's say we go back to this series and we want to find what is the fourth term. So we have the first term and we know the difference. That two things we know. So the first term is 1. We want to find the fourth term, so 4 minus 1, and difference is 2. So that is 1 plus 4 minus 1 is 3. 3 into 2 is 6. 6 plus 1, 7, which is actually 7. So if we have a, let's say, a series something like this: 1 plus 3 plus 6, sorry, it will be 5, so something like that. 5 plus, maybe it goes for certain terms, say 50. So we want to find the sum, or maybe we want to find the ninth term first. So ninth term, what is ninth term? So that will be again t9, a plus n minus 1 into d, and a is 1, n is ninth term, and d is again 2. So that's 1 plus 8 into 2, which is 1 plus 16, that's 17. That's the ninth term. So the sum actually, let's say, it goes up to 51, because 51. So we can say what is the sum. Sum is n over 2 a plus n minus 1 into d. But we don't know how many terms are there. N is the total number of terms here in this case, so we don't know that. So how to find that? Because we know that the last term is 51. So what we can do is we can use that thing here. So last term is 51. So if we do that, Tn is a plus n minus 1 into d. So what is the last term? That's the 51 is the last term. A is 1, n minus 1 into 2. So that gives me 50 here is equal to n minus 1 over 2. So that is n is equal to 25 plus 1, 26. So we know there are 26 terms because nth term is 20, 26th term is 51, and that is the last term. So that's how we know there are 26 terms. So now we can substitute back here and we can find the sum. So yeah, n minus 1 I won't do this calculation, but that's how we do it. So there are a few other applications. I will few applications of this arithmetic series. I will do some of them later maybe.